All right, so let me just give you the rule. So if you plug in negative x and you get the same thing that you started with, that's even. So that looks exactly the same. If you plug negative x in and it's the opposite of what you started with, in other words, if you multiplied the function by -1, that's odd. And if you plug in negative x and it's not the same and it's not multiplied by -1, then it's neither. It doesn't have to be even or odd. So maybe, I think the one on yours was neither, if I remember correctly from yesterday.
The top is negative, the bottom is positive.
I'm pretty sure that you said that we could use a calculator for 3, and I'm just going to use a calculator.
Okay, that's 1-to-1. So 1-to-1 means it's both a function and its inverse is a function. So if it passes vertical line test and horizontal line test. Even functions, if you're looking graphically, which you can do, if you look graphically, an even function is symmetric about the y-axis. If you use the y-axis to cut it in half, it's the same on both sides. And odd functions have rotational symmetry. So if you rotate it 180 degrees, it maps back onto itself. So that's graphically versus algebraically. And you can do it either way. Well, I think that's the one where it gave you, is it odd? I mean, like, option 1 is it's even, option 2 is it's odd, and option 3 is it's 1-to-1. And so you pick which scenarios it fits. Okay, so that's not on 2. I mean, that's not 1-to-1 because it doesn't pass horizontal. No. If you come right here.
But yeah.
It is.
Wait, so it can be odd and 1-to-1?
Yes.
How would it be positive, or how would it be even in 1? How would we know? Odd and 1-to-1. Just like, for it to be 1-to-1, it has to have both positive and negative sign. But
if it's symmetric about, it wouldn't be.
So it would have to be odd.
Mm-hmm.
So it would always be odd.
All odds are not 1-to-1.
But all 1-to-1.
Right.
Right.
There's probably some weird.
And then, well, not necessarily odds. They could be neither. It doesn't have to have symmetry, and it could still be 1-to-1. Yes. So it passes vertical and horizontal line test, right? And if you rotate it 180 degrees, it still looks exactly the same.
Yeah, so what does that mean then?
So that means it's odd and 1-to-1. Yes, and you'll have to give me the
number. What makes it not even? What makes it not even?
Let me see if I can.
I kind of forgot how to do
Okay, so this would be a non-calculator problem because
I figured out how to
okay, you figured out how to graph it. You're just looking at domain and the thing is working. You're just looking at domain and range then, right? Just range. Okay, so domain is left to right, right? So we're looking at anything that x cannot be, right? Right. In that case, there's nothing that x can't be. There are some restrictions on y though, because it is a
downward
it's an absolute. It's an absolute.
Is it just a negative? The range.
But like it could be a value above 2
for range. That's up and down.
Range is bottoms up.
2 is the maximum y-axis. Like literally just like the skeletal y-axis is not there. I'm looking at how far I can go left to right.
So I don't have those memorized, and the reason I don't have those memorized is I derive them as I need to. So if it's secant x, I'll do 1 over cosine, and I'll come over real quick and do. That's absolutely. And that's probably bad on my part that I never memorized them, but my brain was full, yeah. But you can do that. Because it's going down, man. So you have to do the smallest value first. So you said it looks something like this, right? What is this point? But what's the coordinates there? Right? So the range, the lowest the graph ever goes is negative infinity because it goes down forever. And then it goes up, but it stops right there. So since it's range, you're talking about y values, so you pull the y value there, which is 2, and it is a bracket because it includes it. Yeah.
Yeah, that was the same thing.
Wait. One step.
I had to look
Why
at
is
this.
it not?
Because it's not symmetric about the y-axis. It's shifted over. If it's shifted over at all. For which section? The first section? What page are you on?
108.
108.
It is symmetric though.
This one?
Not the y-axis is not the axis of symmetry, though. You did it wrong. You typed it in wrong again, Dylan.
That's what it looks like.
We're talking about absolute value. You're on that one. The y-axis does not cut in. If that was a mirror, the y-axis was a mirror, does it look the same on either side?
No.
No.
But it doesn't on the X either.
It's not the x for odd. It's rotational symmetry. So 180 degrees,
Then what?
then it's odd. You want me to show you what it looks like?
Rotated at 180 degrees.
Allison, I promise I'm coming on that.
It
Give me
should
just
be
a second.
able to.
Hold on, I'm gonna show you. Rational function theorem. That's PRZs, right? I don't know. I have to look at which number is it?
That's where you have a rational function and you have to you know how, remember, if the degree of the top is bigger than the bottom, then you have to try and then there'll be a slant and all that stuff. It's almost like.
But that's not rational zeros. That would be for asymptotes. What 108? Is that what you said?
108 number 6.
Number 6? 7.
You can't plug in.
I would definitely use L'Hopital there.
I already did that.
I would use L'Hopital's there because even though it's, and I'm coming, Dylan, held on to your question about even or because as soon as this is up, I'm going to show you a. Where do you see it saying that?
The solution set.
Okay, I would not do all that work. I would use L'Hopital's there. And I would get 15x squared over 40x plus 10. I would do it again because it's still giving me, because infinity squared over infinity, if you're adding 10, that's not going to make a difference. So 30x over 40, which would be infinity over 40, which is infinity.
No, it's infinity.
Oh, it's because it's the limit as x goes to negative infinity. So I got A there. Is that what y'all got? Is that the answer?
It didn't tell us the answer.
Don't do, I don't, so. Does that make sense? Using don't follow every time. There's not always one way to do a problem. I would never try to find rational zeros of this problem to find the limit there. L'Hopital's is all, if you can ever use L'Hopital's, use L'Hopital's. Oh, hospitals. It will make your life, it will cut out, because remember, you've only got 2 minutes per question on average. You don't want to get sucked into doing some, yeah, I mean, heck, I could do polynomial long division on that and go from there. And but why would I want to do? You know what I'm saying? Like I want to try to find the most efficient way to work each problem. Which one? 9.
Well, number 9, I think that you have to do the inverse.
I'm going, is it not 0 on that one? Okay, so the limit as x goes to infinity, 2 to the negative x over 2 to the x. What's a negative exponent do? Well, if everything is in the bottom, right? If I'm raising 2 to the infinity twice and multiplying it, my bottom's huge. My bottom's going to infinity, right? So anytime I have 1 over infinity type situation, it's 0. That doesn't make sense. Be careful with some of their explanations. No, he's not. There's a lot of good stuff in here, and there's a lot of good problems. And these problems really mimic the AP style multiple choice, which is why we use it. I don't like their explanation all the time, but the practice is good. That makes sense. Close. Any questions like that? Let me finish showing Dylan this because he's been waiting patiently for this. I'm sorry. No, not stop. This will help everybody though, because if you have your calculator, I use this. I cannot believe I did it with y'all. This is what an even function looks like. If you cut it in half, it's the same on either side, but the half has to be the y-axis. If this was shifted over just 1, it's not even anymore. So even reflectional symmetry on the y-axis is the same. Right. I think the most beneficial on this one is showing you the rotational symmetry, which means it's odd. If you rotate it 180 degrees, it looks the same. Right? Does that help you see it a little bit better and understand? Vertical line test, horizontal line test. Yep. That's odd. Oh.
And then after y, wait, you have a question? No. Okay. After Leah and Dwight asked the question, I would like to ask the question.
Okay. Noah, I am really sorry I did not respond. If I ever don't respond, text me again. Yes, because especially if it's late, I'm in bed. But I was sitting up decorating pinafores, and in my hands, I could look at it on my watch, but I couldn't respond. And then I was like, oh, and then I forgot. But we'll answer questions every day. So it really stinks because it looks like I've read them when I do that, but I'm not on where I can, you know what I'm saying? So it looks like I opened your text and then just didn't respond. And okay. What is arctan again? Inverse tan.
Like this.
Funky.
You have been to funky down before?
So arctans, inverse tans, inverse sines, and inverse cosines, because the x and the y-axis are flipped, the domain is restricted so that it's just a portion of it, so that it's still a function. So do you remember what arctan is? Yeah. Which one are you looking at? Well, you could kind of figure out the asymptotes from there, because if x and y are switched, then where it was 0 before is where it's undefined in tan, which means right. So help me. What? All right, I'm going to switch x and y here because it asked me to find an inverse. Did they give y'all too many juices?
I got
I don't know if y'all are going to be able to handle breakfast every morning like that. Alright, it's nasty. I'll stick. Okay. Number 6 says find the inverse. Find a formula for the inverse.
So is that 15 equal to 5e later what?
Well, so the goal here is to solve for y, right?
You don't have to do that at the very end. This may be-
What?
You can just do that for y, read that x, and you do it and make your life a whole lot easier.
Wait, so what'd you do? Just made
Dude,
X
what?
Y?
I'm going to multiply. I'm going to cross multiply. I switched x and y. Because that's how you find an inverse. Oh, yeah, I'm doing the same thing. That's what I did. You just switched your x and y at the end instead of at the beginning. You solved it for x. I'm going to distribute that x through. Remember, I'm not solving for x this time, I'm solving for y because y is the inverse here. Well, the problem with that, man, is because I already had it factored out to start with. Now, if you wanted to just divide both sides by x there, so that here this is, you could do that. You could say 5e to the negative y plus 2 equals 15 over x. Essentially, yeah. So we'll stay over here since that's the way you did it. Subtract 2, and then do what? Divide by 5, right? So I've got e to the negative y. Instead of dividing by 5, I'm going to multiply by 1/5. I'm finding y. That's exactly right. Now, finding y. Yeah. I'm going to write this a different way, and I'm going to clean this up a little bit. So this is going to be, we had breakfast delivered, Coach Kersey. Isn't that cool? Right, I'm going to have to get, all right, so watch what happens. This becomes 3 over x, right? And this is 2/5. Okay, so I had to get rid of this. So I multiply both sides by 1/5. Come to learn some calculus with us.
Yeah, man. If I do well. Yeah.
They're stressing about their test Friday.
Oh, yeah. I'll be all right.
It's a test and a half. It counts a test and a half.
Mach 2 with your hair on fire, right?
Woo! Good, good. How about you? I understand.
Chasing them.
Yeah. Crazy. It's into one fraction.
Wait, so you're gonna, wait, you mean the right, you're making a one fraction common denominator?
Yes.
Common denominator.
Yes, you.
Why? I can make this 15 over 5x. I can make this 2x over 5x. So I can have 1 over e to the y equals 15 minus 2x over 5x. And I did that so that I can flip both of them. Yeah. Because I can't solve it like it is right now. So I'm going to say e to the y equals 5x. This is a handy little trick that if you don't know how to do that, know you can do it now because it will help you. It will save you a lot of time. As long as you flip both sides. If you have a fraction equals a fraction, you can flip both sides. Right. Now I just have one more step. The variable I need is in the exponent, so I'm going to change forms. This is the b to the x equals a log base b of a equals x. So the natural log of 5x over 15 minus 2x equals y.
Do natural log of both sides. Just to get rid of the e, right?
Right. No. Yeah. You can think of it like that. I think of it as changing forms from logs to exponentials and back forth. But yes, you natural log both sides to get rid of the e. That's fine. I did.
Your solution, the way you did it on paper, was a lot easier.
Did I write solutions for these?
You did.
I thought it was just answers.
You wrote it all out. No.
Oh,
It's not working. I was like, thank you.
I didn't even know I put that in there.
What'd you say?
Oh, I did. I remember now. Oh, well, you're welcome. I did this last semester, I'm not going to lie. That's why I forgot.
Yeah, I did see that. Where is
Solutions, so it's not just answers.
What about 4? Wait, let me look at this one.
Yeah, I don't know.
All right, where did you get that equation?
Yeah.
I was looking at one I did last year. I was like, oh, my nails look so good. I should write them out.
Where did you get that equation from?
Which equation?
Number 4.
Pert. Pert.
What is that?
Whenever something is compounded continuously, you use pert.
I never heard of this. What do you
First 30 for you.
Yes, you did. Remember whenever we did the finance project in Algebra 2? We had A times 1 plus R over
I do remember that.
N to the
That was
N
pretty
times
out.
T, or we had per. This is, and I told you, this is the most commonly used. This is continuously compounded.
All right, so how do I use that for 4?
All right, so P is my initial amount, R is my rate, and T is my time in years. So I used an arbitrary amount to plug in and then solved it for, bless you, solved it for T. I want to see how I did the one what y'all are talking about.
It's right there. That's it.
No.
That's the one I'm talking about.
Well. Yes.
Okay. Yeah.
That doesn't look good.
All right, so how do you? No, you're not welcome. So how do you?
So y'all like solutions written out like that as opposed to just the answers. But are you using them to help you and not just writing, like you're not looking at the problem going, I don't even know how to start it, and then flipping to the solutions and looking, right? You're trying.
Because that
Okay.
won't help us. No, the solution doesn't
Okay.
even tell us how to do it, it's just the solution.
The solution does tell you how to do it. It's the answer that doesn't tell you how to do it.
But whenever I go look at the solutions for this, it just gives me the answer that.
How do you use part 30?
So it says, what number are we on again? 4. Determine how much time is required for an investment to increase 5 times the original amount, right? So an arbitrary amount, I said, think about it as having $100 to start with. When will that turn into $500? The rate, it says, is 5.8%, so 0.058. And I'm solving for T because I want to know how long it'll take for that to happen. So 5 equals e to the 0.058 t, and now I can change forms or log both sides, Van. You have to do it. The percent is a decimal. So
Oh wait, no, sorry. There were 2 decimals.
All right, anyways. Okay. So you do log 5, natural log 5 was what? I can't see about that.
I would probably, well, it depends on what type of situation you're in. If you're multiple choice, you'd probably need a calculator to find out what that is. If you're in an FRQ situation, just leave it. All right, 0.058. I don't know, take out your calculator. What's log 5 divided by 0.08? Well, remember, this is supposed to be, you're supposed to be doing it in class too. It's supposed to be classic and homework. So essentially, so about 27.7 years. Take a long time to, but you're only making 5.8% interest. So yeah. A19 and Barons.
I don't know if we're gonna be able to have all this time on Friday.
You're gonna have
So I'm looking at A19 as being a L'Hopital situation because I got 0 over 0, right? So what's the derivative of the absolute value of x? That's on your sheet. Huh?
No, listen. Remember when I had to take you out to take absolute value, the derivative?
Oh, I do remember that.
If you just,
No, you can, but you still have to.
But you would have to know the derivative. Is it 0? Oh, it doesn't exist. Oh, it doesn't exist because it's a corner.
Ah.
So that's why it wouldn't exist there.
if you just did 0 divided by 0, you get 1. It's 0 divided by 0.
No, that's indeterminate. It's undefined.
Anything divided by itself is 1.
You just. No, that's just.
But you can't, yeah, it's not because of the. There's no shifts here, left, right, up, down, anything like that. So my corner there is
So
0.
how do we know that this is a corner? Because it also could be a fraction.
Well, absolute value is a 1.
Absolute value.
No,
is
but
all.
I'm saying like it's divided by x. So how would we know what that graph is?
Well, you know it's still at 0. You know that corner's still at 0 because it doesn't have any shifts in it. There's no plus or minuses in there. What else? Did y'all get through all the last night?
All right, I got tired. Number.
A8?
Yeah,
B8?
I'm on this side, yeah.
Did you see the solutions? It might help.
Oh, I know.
0.98 to the x equals 0.5. Change the form. That's just a straight log problem. The log base 0.98 of 0.5 equals x, and you use your calculator.
Oh, wait, why do you use log?
Natural log's only with e.
So, like,
So remember, b to the x equals a changes to log base b. There. It's there.
Number,
30?
no, well, I don't know. Number 11.
11. Are we in the packet or are we in the Barons?
We are in the. So I can't remember my,
The theory is the top of the wave.
Well, but so you have, did I not put this in the solutions either?
no, wait, no, that's a freaking
I feel like,
period.
oh, yeah, this is what I wanted to show you. We just did this in pre-cal, but y'all lacked in pre-cal. What were you?
No, I had.
You may want to write this down somewhere so you know because it could pop back up.
Are you allowed to use your calculator on this?
Huh?
Are you allowed to use your calculator?
This is non.
I wouldn't have.
Okay, well look, let me show you. So cosecant is just 1 over sine, right? So
It's just like you just forget stuff. So
I understand. So
It's
1
like I
over
feel like I'm
sine,
slow.
everywhere sine is 0 is an asymptote because I'm undefined, right? And that's how I think about it. And then secant and cosecant look the same as far as the parabolas up and the parabolas down. It's just where they start. So you'll just need a starting point. So you could find cosecant of, say, 0. And so is sine, what is the sine value? Actually, that's 0. So that'd be cosecant of pi over 2, right? Which would be positive 1. So pi over 2 on positive 1. Okay. This isn't any sinusoidal graph. Okay, and so I put all this in here so that you would know what each thing did if you didn't have a good pre-cal background here. Period is always 2 pi over b, but you have to know where b is. So this is A. That has to do with your vertical shrinks and stretches, reflections over x-axis, right? You have to factor out, see, originally it was written like this. You have to factor that B value out here to find your, yeah, you have to do that because you have to be in the form of A and then whatever your sine, cosine, cosecant, secant, B times X minus H plus K. Because if you didn't, you would think that you were shifting right pi, but you're not. You're shifting right pi over 2. So period is always 2 pi over b, okay? But you got to get your b from the equation. So that's what period is pi. What did part B ask you?
I remember we did
This is, everybody struggles with this. Part B is the domain. So again, where is my sign 0? But then I have to shift it, right?
Yeah.
So here,
reflect. That just means like negative.
yes. But remember, the cosecant graph is going to look a little bit differently than a normal graph.
I'm gonna be honest. I do not know.
This is a tough one. This is probably one of the toughest ones, but this is so steeped in pre-cal. I think the things you will struggle the most with, that even whenever you do have a good pre-cal background, it's still a struggle, are your trig graphs, especially the cofunction graphs and transformations on those. Sine and cosine, not so bad, but the cofunction graphs. And then the trig identities always are just, oh.
I remember when I was in pre-cal.
7 on 144. Next section, please.
I did have one.
What?
It's a quick question. How would number Roman numeral 3 says that the function of 0 equals the limit?
I said the limit as x goes to 0. Yes, they're the same because it's defined right there.
So that would be true?
Yes.
So if we all three of them do it?
Yes. Which one did you say, Lizzie? A37. And you know I said odds, but you know don't do any of the ones that say BC only. Right? Y'all figure that out. Okay. Like on page 146, 53 through 56 say BC only. And on page 144, 30, 33, 34 are all BC only. 51 is BC. Don't do any of those. All right, what did it ask you to do for these? I got to find the directions. Find the derivative. All right. The limit as h goes to 0 of the natural log of e plus h minus 1. So essentially, they're giving you what? Yeah. No. So what can we do? Because this is the definition of the derivative, essentially, is what they've given us, right? So what can we do? We can't plug in 0, so we're going to have to manipulate some way so that we can, right?
Wait, well, let's think about it.
Let's
It's
think
gonna
about it.
be.
Can you like distribute the natural law? Like natural
You
law?
can't. No.
I was thinking that, but it's gonna be -1 over 0. So no, it's not 0.
It's natural log of e is 1
No, because it's still being multiplied.
They're all going to be L'Hopital situation because.
I could have literally.
How did you know that the last natural log of e was 1?
Because it's natural log.
Man, shut up.
We learned this. We learned this like.
Yeah, I think we have.
What does the difference quotient? You can do this, man. What's the difference quotient look like?
Oh gosh, f of x which would be equal. Wait, yeah.
No,
Plus,
just in
alright,
general.
Okay, sorry. Plus h minus f of x all over h.
Well, I just want you to think this because this asked me to find the derivative. But clearly this is the derivative at a certain point, right? Because they plugged in a value for x, right?
This looks like
What is f of x in this case? Natural log of. Would you agree with that?
wait, hold on.
If f of x is the natural log of x.
Wait, hold on. Why? I thought it would be the natural log of e plus the natural log.
Well, they've already plugged something in here, and I know that because I've got a specific value here, and here I've got something plus h. Well, because I've got something plus h, if this is my function, I'm thinking that they plugged e in. So I'm thinking that this is the derivative at e. Does that make sense?
I see how that's like, I don't know how I would do that. I understand what you're
I wouldn't realize I had to use the gun
Okay, well then that's what this is doing is this is testing your knowledge of difference quotient. That's all this is doing.
Since they set it up like it looks so similar to the original equation, that's how you know what's correct.
Oh, I know.
Yes.
Shut up, the radio's so ugly.
Is that the answer? Is it B? Please be B. Okay. Let's see what happens if we try to do L'Hopitals here because somebody said L'Hopitals. And listen, if you're on multiple choice, and this is what I was trying to tell you, if you're on multiple choice, they may be trying to test you on something, but because of the knowledge that you have of future stuff, like now you know L'Hopitals. When we were doing this, you didn't know L'Hopitals, right? But now you do, so if it's something, let's see what happens if I did do L'Hopitals. Derivative of the top. What's the derivative of this? 1 over plus h, right? And the derivative of 1, and this, remember, if there was a variable on that h, I'd have to do chain rule, right? Okay, and I'm not doing quotient rule here because L'Hopital says just do the derivative of the top and just do the derivative of the bottom, but don't let that confuse you whenever you start taking, right? Right, so it's just 1 over e plus h. So now if I do the limit as h is to 0 of 1 over e plus h, look, L'Hopital's work.
Yeah. I'm pretty sure we're just going to use L'Hopitals for all of them.
I love L'Hopitals, and I will, you will, and it saves you so much time, doesn't it? Well, because you didn't know derivatives whenever we were doing limits, you know what I'm saying? Your book doesn't bring it up until like chapter 7 or 8, like unbelievable. But I like to teach you, and that's why I always go back as we're reviewing now. You still have to know it because they'll. Right. Well, I have seen questions that would say which one of these represents the derivative of the function, and they will all look like different difference quotients. So you'll have to know how to use saying? So you will have to know because it could be in the multiple choice questions and not the, so, yes,
On
no.
A3, on there, whenever you take out common denominators, like.
A3, are we in first section or second?
First.
Okay.
Whenever when you check your, you get x minus 3 over x plus 1, x minus 3. Whenever you get rid of those x minus 3, is that 1 on top? Is that x minus
1.
3 on top? One?
Wait, which number
You
is
just have a placeholder, so
Right.
that's why.
Now, that could also be 9 minus, that could also be a L'Hopital situation on that
I
one.
know, think about
That's what I would do there
it.
too.
Candy look on
I'm a L'Hopital fool. I will do L'Hopital on every time I can because listen, taking the derivative of a top and a bottom, it's not even quotient rule, just straight derivatives and then plugging in. I would much rather do that. And it eliminates a lot of algebraic manipulation that you get if you learn to use L'Hopitals. Yeah, I agree. Okay, because average velocity talks about, which one are you on? So, no, because that's if you're using instantaneous velocity, then you would use that velocity equation. But whenever it says average velocity is AROC, and it's AROC of the position function. Because when you find the slope of position, you have found velocity. Does that make sense? Okay.